A pellet of this metal, smaller than your fingertip, holds as much energy as burning a full ton of coal. Packed the wrong way, that same element can level a city. It's powered entire nations and ended a war in 2 blinding flashes. So what actually is uranium? Let's break it down. Uranium is a naturally occurring metal, element number 92 on the periodic table, meaning each atom packs 92 protons into its nucleus. That makes it one of the heaviest natural materials on Earth. Pick up a chunk of pure uranium and you'd feel it immediately. It's about 19 times denser than water. That density isn't just a curiosity, it's why this metal can hold so much energy. Uranium was first identified in 1789 by German chemist Martin Heinrich Klaproth, who found it in a mineral called pitchblende. He named it after Uranus, a planet that had only just been discovered itself. For the next 100 years, nobody knew what they had. Uranium was mostly used to make glass and ceramics glow a yellow-green color. Then, in 1896, everything changed. Henri Becquerel left a uranium sample near some photographic plates, and the plates fogged over. Something invisible was coming off this metal. That accidental discovery cracked open the entire field of radioactivity. The field was later expanded by Marie and Pierre Curie. A glass ingredient turned out to be a most consequential material. Uranium atoms are unstable, they decay. And there are different versions of them, called isotopes. Natural uranium is 2 isotopes. Uranium-238 makes up 99.3%. Uranium-235 makes up just 0.7%. That tiny sliver is the important part, because U-235 is fissile. That means if a neutron strikes it, the atom splits apart and releases a massive burst of energy. That splitting is called fission. It's the exact same reaction happening inside a nuclear power plant and inside a nuclear bomb. One atom splitting releases a tiny amount of energy, but multiply that by trillions of atoms, and it adds up fast. In a power plant, uranium fuel rods sit inside a reactor. The atoms split in a controlled chain reaction, releasing heat. That heat boils water into steam, and the steam spins turbines that generate electricity. No burning, no fossil fuels. That's why uranium plays a major role in the conversation around clean energy today. But the same reaction, left uncontrolled, becomes something else. During the 1940s, the Manhattan Project figured out how to enrich uranium. The bomb dropped on Hiroshima in 1945. Little boy ran on highly enriched uranium. One reaction, 2 completely different outcomes. That single fact is why uranium isn't just a chemical element anymore. It's a symbol of energy independence and of mass destruction. Uranium is mined out of the ground, mostly from a handful of countries. Kazakhstan and Canada produce most of the world's supply. The raw ore gets processed into a concentrated powder called yellowcake, which is then converted into reactor fuel. Mining it raises concerns about water contamination and worker exposure, which is why the industry runs on strict safety protocols. Natural uranium is only weakly radioactive. You wouldn't want to inhale the dust, but simply being near it isn't an immediate danger. The real risks come from its decay products and high radiation environments, not the raw metal itself. A powerful resource, shaped by our choices.